Hello again. This is Math 2231 coming to you from the College of DuPage, and the title of this lecture is Function Review. As always, please be an attentive learner while watching this video. Previously, we reviewed algebra and analytic geometry content, and this is going to continue our work, and we're going to discuss functions. So after completing the algebra and analytical geometry, we do turn our attention to functions. And this is like doing stretching exercises prior to doing some running. Once we begin our run, we will review things just in time and within context. So here's a problem number one for you to attempt. The graph of a function f is given on the left, and as always, y is equal to f of x. So we're to state the value of f of minus 1, estimate the value of f of 2, determine for what values of x is f of x equal to, estimate the values of x such that f of x equals 0, and state the domain and range of the function f. So give it a go. And those of you who solved this, congratulations. Otherwise, we'll just see how you did and we'll learn from that. So to find out f of minus 1, we let x be minus 1, and we see that y is minus 2. We want to estimate the value of f of 2. So that means x is 2, so there is 1, there is 2. We go up here, we find out that this is about 2.8. If we say for what values of x is f of x equal to 2, we can say that means that y is equal to 2. So y equal to 2 is across here. We see there are 2 times that happens. And so it is equal to 2 at minus 3, and is also equal to 2 when x is 1. So those are the values of x, where f of x is equal to 1. We're to estimate the values of x such that f of x is equal to 0. Well, f of x equal to 0 means y is equal to 0. So it is this point and this point. And if you look at the number line, you would guess that this is minus 2.5 for this one and 0.3 for this one. And estimate the domain and range of f. Now this requires us to remember that the x values that we see in play, namely going from here over to here, is minus 3 to 3. These are in interval notation, and the minus 3 and 3 are included, as well as all numbers in between. Now the range is the set of y values, and you see the y values that you visit as you traverse this function go from minus 2 all the way up to 3. And so those are the domain and range of f. The next question, if f of x, that's y equals f of x, is equal to x cubed, evaluate what's known as the difference quotient. And that is defined in this way, is f of 2 plus h minus f of 2 all divided by h. And you're to simplify your answer. So please give this a go. Let's see how you do. Now, this says that to find out what f of something is, you just take whatever you plug in between these parentheses, whatever is the input, and you cube it. So f of 2 plus h is 2 plus h whole cubed. F of 2 is simply 2 cubed, which is 8 divided by h. But now we have to simplify this, so we have to expand this. And so we want to expand this. This is 2 plus h times 2 plus h times 2 plus h. And there's a number of ways we could do that, or you could use a binomial theorem. But this is going to be 8 plus 4h plus 2h squared plus h cubed minus 8. Now notice that the 8 and minus 8 will cancel out, and each of these remaining terms has an h in it, which I can factor out getting this, but then the h in the numerator can cancel with the h in the denominator, and I get as an answer 4 plus 2h plus h squared. Here we're to find the domain of the functions. Now, the domain of the function is defined to be all values of x such that, unless otherwise specified, it is defined to be all value of x where the answer makes sense as a real number. That is, f of x makes sense as a real number. So you want to find the domain of these three functions. So please give it a go. And let's see how you did. Well, you can't have a 0 in the denominator. So that means x can't be 1, else this would be 0, and x can't be minus 2, else this would be 0. So those are the only two values that you can't have, and so that means it's all real numbers except for those, and that would be from minus infinity to minus 2, union from minus 2 to 1, union from 1 to infinity. Now here, x squared plus 1 is never equal to 0 when x is a real number. If x is 0, we would give 1. If x was negative, x squared would be positive. And if x is positive, x squared is positive as well. So you see, you don't have a 0 on the denominator here anywhere. And you can take the cube root of positive, negative numbers, or 0. So you see, this makes sense for any real number that you pick. And so the domain is all real numbers, or written in interval notation from minus infinity to positive infinity. Now, the part C is y is equal to h of x. Now here you have two things, and both of these expressions have to make sense in order for this expression to make sense as a real number. So for here, x has to be less than or equal to 4, because otherwise you'd be taking the square root of a negative number, and you can't take the square root of a negative number within the real numbers. And the other thing here is x squared has to be bigger than or equal to 1, or else you get a negative here. So that means we're taking this interval, which is shown geometrically here, with this interval, which is the same as the absolute value of x being greater than or equal to 1. Now that says that x is greater than or equal to 1, or less than or equal to minus 1, but both of these must be true. All of these must be true. That is, this one intersected with this one has to be true. So that means that the answer is from minus 1 up to 4, the endpoints both included, and all numbers in between. Question 4 asks, how are the graphs of the functions obtained from the graph of x? So give these three answers a go, please, and we'll discuss them in a bit. Let's see how you did. Well, here, since you take f of x and just make a negative of it, you're reflecting the graph of f of x, or y equals f of x, about the x-axis. Now here, what you're doing is you're multiplying the value of f of x by 2, that is stretching it vertically by a factor of 2, and then shifting 1 unit, but since it's minus, you're shifting down. And C is the most complicated of all, but here what you're doing is you're shifting 3 units to the right and 2 units upward. Again, we will often be graphing things like this. Again, often we won't be using calculators, so without using a calculator, make a rough sketch of the graph. So here are 8 graphs that you want to figure out how the graphs are and sketch them. Let's see how you did. Well, if y equals x cubed, if it's negative, it will be negative, 0 is 0, and then it's positive, and it grows very fast. And this one is the same kind of graph for B, but it's just shifted 1 unit to the left. Notice that it's a little bit counterintuitive because it is plus 1, but that does shift it to the left. And C, we get 2 shifts going on. We shift it 2 units to the right this time, and up 3. So you see this graph is shifted 3 times. Here we look at this one. This is opening downward. It is a downward opening parabola, but then you shift it up 4. So this is what we get for D. The domain of this one is x has to be greater than 0. So we get that. And here we stretch it vertically by a constant. Here we take y equals 2 to the x, which is an exponential function, but then we multiply by a negative, and that is reflecting this about the x-axis. And last but not least, 1 over x has a vertical asymptote at x equal to 0. That's a vertical asymptote, and it has a horizontal asymptote because as x gets very, very large, the end behavior of this gets closer and closer to 1. So it's the graph of 1 over x shifted up by 1. Here is a piecewise defined function. So we let f of x equal, it's 1 minus x squared if x is less than or equal to 0, and it is 2 plus x if x is greater than 0. So if you want to evaluate, so we want to evaluate what is f of minus 2, what is f of 1, and sketch the graph. So please give this a go. Let's see how you did. Well, for minus 2, we use the top definition, and when we put minus 2 squared is 4. This is 1 minus 4 is minus 3. 1 is bigger than 0, so we put 1 in here and we get 3. So those is how you evaluate that. Now here, if x is less than or equal to 0, you're graphing 1 minus x squared. So as upside down parabola, shifted up by 1. If you are bigger than 0, what will happen is you will get a line has a y-intercept of 1 and a slope of 2. So you get this for B. Piecewise defined functions are often encountered in calculus. And finally, we have two functions, and we'll talk about the composition of functions. So f of x is x squared plus 2x minus 1, and g of x is 2x minus 3. And we're to find each of the following functions. This is f composed with g, this is g composed with f, and this is g composed with itself 3 times. Please give this a go. Let's see how you. Okay, so f composed with g means that's f of g of x, but that means that g of x is performed first, so we have 2x minus 3. So this is f xing on 2x minus 3. So we plug in 2x minus 3 instead of x, so we get 2x minus 3 whole squared plus 2 times 2x minus 3 minus 1. We simplify that, combining like terms, and we get 4x squared minus 8x plus 2. Now g composed with x, with f, is something different. That is g of f of x. First we do f of x. So this is going to be g of x squared plus 2x minus 1. And so this is 2 times whatever we put in there minus 3. We distribute and do the calculation and simplify, and we get 2 times x squared plus 4x minus 5. Note that f composed with g is not the same thing as g composed with f. And here we're doing g composed with it several times. So g of x is g of g of x. So this is this, and then this is going to be g of that. Now that is going to be 2 times 2x minus 3, all minus 3. And if I simplify this, this is g of, that is 4x minus 9. So there's going to be 2 times 4x minus 9 minus 3. And when I do the final simplification, I get 8x minus 21. Here's a summary for the answers for the first page. And I showed you the answers for the second page as well. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. We're all in this together. God bless you all.